Okay, so graphing rational functions. In part one, we graphed some different types, and we started off with what I call the crosshair type, and that would be when the numerator is a constant. So if you had something like this, numerator is a constant, and then that's going to be the crosshair type, where you make the crosshair and get, well, this particular one. The curves will be in those two corners, okay? And then we also looked at one type where there was a variable in the numerator, and sometimes those are going to reduce to be a line with a hole in it, and they would look something like that, okay? If it doesn't reduce and it has a variable in a numerator, then we've got some new situations. And that's what I'm going to cover today in part two. Okay. So the first type is when the numerator degree is the same as the denominator degree, and I call that balanced. So if I had something like this, for example, then the top has a degree of 1 because it's x to the first, right? And the leading coefficient in the denominator is also 1. I mean, the degree of the leading coefficient is all. The leading term is also 1. So first degree, or if you had x squared and x squared, something like that, that would also be what I call balanced, okay? And when that happens, we're going to need to find the intercepts and the asymptotes, okay? So the x-intercept is, what you're going to do is set the numerator equal to 0. And I'm going to run through examples on this, but this is just getting some basic ways to get these intercepts and asymptotes depending on the situation. So the numerator in this one, I'd set x plus 2 equal to 0. Okay, and that would actually come out imaginary, but often it wouldn't be imaginary. Okay, the y-intercept is always going to be the line x equals 0. Okay. Then we've got a vertical asymptote, and what you're going to do is set the denominator equal to 0 to get the vertical asymptote, okay? The horizontal asymptote, it's got to be the line y equals something, and it's going to be y equals, and then we've got a fraction. So the top is going to be, it's going to be the leading coefficient of the numerator, okay? So the leading coefficient up here would be 1, okay? Then on the bottom, I'll take the leading coefficient of the denominator, which for this example would also be 1, okay? And again, I'll show this all in a couple examples here in a second, but I just want to get this flow chart to organize the different types, okay? And then when the numerator is the degree of the numerator is greater than the degree of the denominator, or you could call that top heavy, it might look something like this. If I had x to the third over x squared, something like that, right? The degree on the top is bigger than the degree on the bottom. That's top heavy, okay? And we still want to find the intercepts and asymptotes. So the intercepts we can find just by plugging in zeros, okay? These are just little shortcuts of how to find those, but you could still just plug in zeros for the x's and y's, all right? But the horizontal asymptote, I'll just put HA for horizontal asymptote, doesn't exist. There isn't one. So that's good news, but the bad news is instead we've got a slant asymptote. Okay? So what we're going to do to find, so that means instead of having a horizontal line that my curve is going to follow as a guide, I'm going to have a line that's on some sort of a slant asymptote, and the curves might hug a slanted line like that or like this or something, okay? And what we're going to do to find that is we're going to do some division. And again, yeah, I'll get into the details soon. But now we've got this flow chart to kind of help you figure out what to do if you have a problem and you don't know which road to go down. So you can find your way down these roads just by first seeing if the numerator has a variable or not, okay? All right, so let's try out some different examples on the following pages. Okay, so So let's take a look at the next page. So looking at this example, I'm going to graph this. So first thing I'm thinking is that this does have a variable in the numerator, okay? So then will this reduce? So might want to try factoring this. That's always a good first step, because sometimes you can simplify things in a big way and it makes life easier. So factoring this, I can see it's not going to reduce. So this is not going to be just a line with holes in it, okay? So that's kind of sad, but factoring it is still going to be helpful, okay? So this doesn't reduce, and then so I need to look at my next two options. I want to think, does the numerator have the same degree as the denominator? In this case, it does, right? This is second degree, both on top and on bottom. So I'm going to go down this path that I've got here, okay, as opposed to if this were a top-heavy one, okay? So let's start finding the intercepts and asymptotes. I'll just go in this order. So the x-intercept, you can just plug in 0 for y, but then I'd have 0 equals this fraction, and the first thing I would do if I had 0 equals the fraction is I'd clear the fraction by multiplying both sides by x squared minus 9. And then 0 times x squared minus 9 is 0. So and then I'd have 0 just equals the numerator. So it's just a little shortcut. You can just take the numerator and set it equal to 0. Okay? And since I already have this factored, I can choose which numerator I'd rather set equal to 0. I might as well use the factored one, because if I set that equal to 0, then it's all set for 0 product property. Okay? Because one of these two things has to equal 0 then. So either x equals 0 or 3x plus 1 equals 0. And that means I've got two different x-intercepts. Okay, so here. And I'm just going to go ahead and graph this as I go. So I'm going to put those two into the graph. I've got 0 for an x-intercept, and negative 1/3, which is pretty close, something like that. It's kind of hard to graph because they're so close together. But those are my two x-intercepts, okay? And now let's start working on the y-intercepts. So going back to my chart from the previous page, sorry, let me get this. The y-intercept is going to be 0, which makes sense because I've got an x-intercept at the origin, so I've also got a y-intercept there, right? And I could also just plug in 0 for the x terms. So really, when I say x equals 0, I'm plugging in 0 for x into these. Okay. So I got a lot of different places to plug in 0. But then this is going to simplify pretty quickly, right? 0 squared times 3 is 0 plus 0 is 0. So the only thing that's going to be left here, I'll have 0 over negative 9. And then 0 divided by anything equals 0. So it makes sense that I've got that, that intercept at the origin, which I've already got graphed because it's right there, right? Okay. So let's move to the asymptotes then. So I've got a vertical asymptote. That's going to happen when I've got undefined x values. So it's going to happen when the denominator equals 0. Okay, so again, I can take x squared minus 9, or I could take the factored version. Either one will work. I prefer the factored version because then, again, it's set up for 0 product property. So x would equal negative 3, or x would equal positive 3. So those I'm going to have goalposts there, right? I'm going to have vertical lines. So let's put those in. One at x equals 3. Make this a little darker here. Here's x equals 3, the line x equals 3, and x equals negative 3 is right here. And then the last piece of this is a horizontal asymptote. That's going to happen using the leading coefficients. Okay? So my horizontal asymptote is going to be a y equals line, because all horizontal lines are y equals lines. Okay? And then I use the leading coefficient of the numerator, which in this case is 3, because 3x squared is the leading term, right? So my leading coefficient is 3 on the top. On the bottom, I've got 1x squared. So my leading coefficient on the bottom is 1, and then that simplifies to y equals 3. Forgot to put a box around those. Okay? And there's my horizontal asymptote. Okay? So y equals 3 is going to look like this. Okay? Now, it's a little bit hard to tell what's going to happen exactly, but I'm going to use these asymptotes as guidelines. Okay? So I'm guessing that I'm going to, since I've only got those 2 points so far, I'm guessing I'm going to have a curve that kind of fits in here, something like this. And then usually a checkerboard kind of thing happens. So I'm thinking there's going to be a curve up here, a curve up here, and a curve down here. Okay? Now, if I didn't have a calculator at my disposal, I could always, plug in 4 for x and see what you get out for y. Or I could plug in 5 or 6 or whatever. I could start plugging in different x values into the original equation to find some more points. Okay? But since I do have a calculator at my disposal, I'm going to go ahead and use it. Okay? So I'm going to go to the y equals button, and I'm going to put my original equation in. Got some other stuff, so I'll just clear that out. Make sure you put the whole numerator in parentheses. That's going to make things easier. So 3x squared plus x. That is my numerator. I'm going to take all of that and divide it by, and then again, I'm going to put the denominator in parentheses, just to make sure my calculator doesn't get confused about what exactly is in the numerator and what's in the denominator. Okay? So I got that all plugged in, and now I'll go to graph. And I do have a weird zoom going on here. I'm waiting for it to stop thinking, those little lines. Okay, it's done. So I do have some kind of goalpost looking things. That's kind of promising. But let's go to our standard zoom. I'm going to hit the zoom button and then go to standard. You could do all this on Desmos, by the way, if you don't have a graphing calculator. So I'm going to my standard zoom. That's kind of it gives you 10 ticks in each direction. And then that actually looks like it fits pretty well with what I got down here. So I'm feeling good about this. Okay? So, green pen, there it is. Okay. So if it doesn't draw in the asymptotes, but if you look closely, it looks like if I drew x equals 3 in, it would guide those lines. Okay? So, and if you zoom in, you can't really see the two x-intercepts because they're so close together, but if you zoomed in, you would be able to see that the part in the middle that kind of looks like a parabola is going to just barely go above the x-axis for a second and then back down that way. Okay? And then I'm going to have some curves that fit here and here. And it might seem like it's a little strange that my parabola didn't go up and kind of hug that horizontal asymptote, but the horizontal asymptote just served to guide on the two ends, so that happens sometimes. Okay. All right, so there we go. All right, let's take a look at another one on the next page. Okay, on the next page, got another one. Okay, so looking at this one, I can see that these are balanced again. So first thing I'm going to do is factor as much as I can. I can factor the numerator by just factoring out an x. The bottom, the denominator, is not factorable. It's not a difference of squares because 2 is not a perfect square. So can't do anything with the denominator there. But now got it factored. Okay, so the x-intercept, we're going to plug in 0 for y, and if I had 0 equals this fraction, I'd multiply both sides by the denominator. So 0 is really going to equal the numerator. So I can choose if I want the factored and non-factored version. I'd rather use the factored one here because it's already set up for zero product property then. So then either x equals 0 or x plus 2 equals 0, which means x equals -2. So there's my x-intercepts. Okay. All right. Maybe I'll graph this as I go. Got to zoom out a lot there, but that's okay. Okay, so I've got 0 and -2 for x-intercepts. For the y-intercept, I'm just going to plug in 0 for the x's. Okay, and then I'll start solving this. So there's going to be nothing left on top. Got 0 divided by -2, and 0 divided by anything equals 0. So it's okay, remember it's okay to have a 0 numerator. You just can't have a 0 denominator. So there's my y-intercept. I'll separate this a little. Okay, then my vertical asymptote, I'll just put VA. That's going to be when the denominator equals 0, because those are going to be the undefined x values. Oh, and I put my y-intercept in there, but it's already on there, right? Because that's where that crosses the y-axis. Okay, so vertical asymptote denominator is equal to 0. And I'll solve this for x. So I'll add 2 to both sides. I'm going to take the square root, and remember when you do that, there's a positive and a negative root of 2, and that's going to come out to about 1.3. Yeah, 1.414, something like that. I mean, I'm not going to be able to get much better than about 1.4, but there's my vertical asymptote. There's actually 2 of them, right? There's 2 vertical asymptotes, okay? So let's put those into the picture. So 1.4 and -1.4. 1.4, x equals 1.4 is going to look something like this. Pretty darn close to 1.5, right? And then -1.4 would be something along these lines. Okay? All right, and then finally, the horizontal asymptote is going to be, that's when I do y equals the leading coefficient over the leading coefficient. So in this case, my leading coefficient for both the numerator and denominator is 1, right? So 1x squared, 1x squared. And that simplifies to just y equals 1. So I'll plot the line y equals 1. Okay. And this one is a little strange when we look at this, but let me get to the graph in a second. Just to recap, this is when the numerator equals 0. Okay. This one I just plugged in 0 for x. This is denominator equals 0. And that was when y equals leading coefficient over leading coefficient. Okay. So it's a little bit difficult to tell what exactly is going to happen when we look at everything we have graphed. Okay, I know I've got my intercepts. I'm pretty sure I'm going to have a curve something like this. Okay. And since I've already looked in the future, whoops, that's kind of bad drawing. But I know that something like that is going to happen. It's hard to tell what's going to happen in the middle. Maybe this comes up and it's kind of a parabola. It looks like a parabola in there. But it can actually cross over the horizontal asymptote, especially in this middle section. Okay, because it turns out that this asymptote is just going to be a guide for the pieces on the ends, not for a piece on the middle. Sometimes you can cross over that in the middle. Okay, so we could try out some different x-y pairs. I could see what would happen with -1, +1, 2, 3, 4. I could just start plugging in things for x, but let's use our calculator to take a look at this. Okay, so I'm going to the y equals place. And then here, let me go back up here. I'm gonna put the non-factored version into my calculator, and I'm going to use parentheses to separate the numerator and denominator so that my calculator doesn't get confused. So I've got x squared plus 2x, close the parentheses, that's my numerator, and I'll divide that by my denominator, x squared minus 2. Okay. And I'm going to graph this. I'll hit the graph button right here. If I've got a weird zoom going in, this looks pretty good here, this zoom. This is the standard zoom. But if you didn't have, if you had a weird zoom going, just hit the zoom button there and go down to zoom standard, and that will give you 10 ticks in each direction. That's usually a good place to start. So I just hit enter on that, and it'll draw it again there. Okay. And so let's see if this fits in with what we have already graphed down here. And it's looking pretty good, right? As I predicted, I have this, this curve on the left side. Now I can see in the middle section, I've got kind of an S-curve, and it is going through the origin. So that's what I thought would happen. So those goalposts that I have, the vertical asymptotes, are guides for drawing this curve. And then I've got another curve that hugs that corner. Okay, and you could verify all of this by, or you could try out XY pairs to get a better sense, but there's a general look at that graph. Okay, let's try one more on the next page. Looking at this one, hey, this one is a little different because on that last one I had a balanced one, right? Actually, the last two problems where the top and bottom had the same degree, but this time the top has a bigger degree. It's second degree and first degree. So this one is top heavy, if you want to think of it like that. So that's going to change things a little bit. A lot of this is going to be the same. So for my x-intercept, I'm going to be plugging in 0 for y, which ultimately means that the numerator is going to equal 0 as a little shortcut. Okay, so actually I forgot, I always like to factor this first. I can factor this with a diamond problem here. So let's go ahead and do that. Put 4 up here and 3. Looking for two numbers that add to 4, same two numbers multiply to 3. It's going to be 1 and 3, right? So x plus 1, x plus 3, all over x plus 2. Okay, so I might as well use the factored version. I'm going to set the numerator equal to 0. Oops. All right, and then it's ready to go for 0 product property. Okay, so there's my x-intercepts at -1 and -3. Just put them in those blanks there. Okay, and I'll graph as I go x-intercepts here and here. Okay, and then let's look for a y-intercept. Or maybe there's multiple y-intercepts. I'm going to plug in 0 for x. And you can use either version there, it doesn't matter. I'll use the original version. Okay, now when I think about what's left, got a lot of zeros in there, and the only thing that's left on top is the 3. Only thing that's left on bottom is the 2. So hey, I've got y equals 3/2, also known as 1.5. Okay, so I'm just eyeballing 1.5. That's where my curve is going to cross the y-axis. Okay, all right, and now vertical asymptote. That's going to be the undefined x value, so that's where the denominator equals 0. Same as before. So I'm going to have a vertical asymptote at x equals -2. I wouldn't just say it's -2 because it's going to be a vertical line. So it's the line x equals -2. All of the points with an x coordinate of -2, and they would all be on this vertical line. So there's my vertical asymptote. So far nothing is different. The new piece is going to come with the slant asymptote, right? There isn't a horizontal asymptote on these types because it's the top heavy ones. It just doesn't exist, okay? So here is the new piece. What I'm going to do for the slant asymptote is I'm going to do the suggested division. So I'm going to take the numerator and divide it by the denominator. So I'm going to take x squared plus 4x plus 3 and divide it by x plus 2, like so. Okay. Now, going back in time a little bit, got to pull back some previous knowledge. Going to go back a few chapters. I can use synthetic division here. You could also do long division, but when you divide by x plus or minus something, a binomial like that, you can do synthetic division. So I'd put a little -2. You set that equal to 0, and x would equal -2. Okay. And then I'm going to use just the coefficients here. And if there's any missing terms, you need zeros in there, but this doesn't have any missing terms. Okay. And then I leave a little space. Draw a little box like that. Okay. I'm going to pull the 1 down, and then I multiply by -2. Okay. Then I add 4 plus -2 is 2. Multiply again. -2 times 2 is -4. Add again. And then I've got this in my remainder box. Okay. So this is going to be the numerator of my remainder. This is just going to be 2, and this is going to be a 1x. If there's another number, it'd be something x squared. But this is going to just start with x plus 2, and then my remainder is going to be whatever you're dividing by here. Okay. So if we think about what this actually means, is that if we take this equation that we had here in the beginning, we could rewrite the right side of this equation as this. Okay? So really, I can say that y equals this. Okay? Now, what's going to happen with this? Let's say we plugged in 100 for x. Well, then it'd be -1 over 98. It'd be a really small negative number, right? If we plugged in 1,000,000 for x, it would be an even, actually, it'd be -1 over 102, sorry. If we plugged 1,000,000 in for x, it'd be -1 over 1,000,002. It'd be a really, really small number, right? And same thing if we plugged in -1,000,000. So when we plug in really large numbers, this numerator is going to get insignificant. It's going to get really small. So what's going to happen is it's going to start acting like just this line. Okay? So at the bigger numbers I put in, the closer my curve is going to come to the line y equals x plus 2. So the line y equals x plus 2 then is going to act as an asymptote. Okay? So that is my slant asymptote. Okay, and you have to know how to graph these lines, of course. So in this one, the slope would be 1. That's in slope-intercept form, right? Y equals mx plus b. And then the y-intercept is 2. Okay, so here, let's graph this. The y-intercept is 2. The slope is 1, so I could go up 1 to the right 1, up 1 to the right 1, up 1 to the right 1, or down 1 to the left 1, down 1 to the left 1, and so forth. Okay? And then this green line then is going to be my slant asymptote. Got that from doing the suggested division in the original problem. Okay? And now you can kind of tell what's going to happen. It kind of looks like, oh, we're going to have a curve that I'm going to use those two as a guide. And this actually works a lot like the crosshair problems, where you're going to get two curves that are mirror images of each other on different sides of the x. So I'm just going to kind of repeat this shape over here. And there we go. Okay. And if you didn't have enough information, you could always plug this into a calculator and see if it fits with what we've got. So let's go ahead and do that. Of course, if you just plug this into a calculator and sketch what the calculator said, the calculator's not going to tell you where the asymptotes are or the intercepts. You can make it tell you where the intercepts are, but I would only use the calculator to check your work at the end. If you're relying on it to do your graphing for you, you're going to miss out on a lot of information, and it will be really obvious if that's all you know how to do is to plug it into a calculator. Notice how I separated the numerator and denominator with parentheses, and then I hit graph. Hey, that's looking pretty good, right? That's looking exactly like what I have here, okay? And that's it for today. See you next time.